everyone, and welcome to our lesson on solving equations. So let's start out with some notes on vocabulary. Then we're going to go into some examples that I want you to just kind of watch as we work through. And then we're going to come back to our notebook and we're actually going to write out some of the examples that we saw on the board for today. So for solving equations, we have some of the vocabulary that we're going to be looking at. Constants basically are regular real numbers, and you'll see a little yellow tile or a red tile to represent constants. They might be squares, they might be circles. The variables are pretty easy to pick out because a variable is an unknown numerical value. This is most of the time represented by a letter, and they are the long rectangular bars. And a coefficient. A coefficient is a number being multiplied by the variable. So I gave you some examples here. You have an x, and in front of the x is a 5. That 5 is called a coefficient, and it's telling us that there are 5 variables. Just like when you were younger, this would kind of be equivalent to saying there are 5 apples, except we use letters in more advanced math. So we would say there's 5 x's. Here we have there are negative 8 y's. Here we have there's half of a w. Okay, and then terms. So terms are, in an algebraic equation, are separated by addition and subtraction signs. And it's really important that we identify our terms. So here's my addition sign. This problem, this expression, has 2 terms. Here's my 2 addition signs. So this expression has 3 terms. And here are some subtraction and addition signs and negative signs. This expression has 1, 2, 3, 4 different terms or 4 different pieces to the expression. Oh, there was the bell. All right, let's kind of move on to some of our examples now. Okay, so let's continue with some of our review. We need to make sure that we remember that a zero pair is one positive constant and one negative constant grouped together. So a positive and a negative together equals 0. Another way that we can do this with our variables is by putting together one positive and one negative variable. So a positive and a negative variable also make a zero pair and will help me get rid of variables. Okay, constants. So let's just make sure we understand our models. 3 positive constants is, you'll see 3 little yellow circles. If I'm talking about maybe 4, let's do 2 negative constants, that would be 2 red circles or minus signs. So you could even, if you don't have colors at home, feel free to use plus signs and minus signs to show that you're working with your constants. With variables, again, you could just draw a rectangle with the positive sign. So let's do, 2 x's would be 2 of our green, since it's positive, 2 of our green rectangles, or you could just do it in pencil and just make sure that you put plus signs inside. If I wanted to do -1 variable, I would just do a same rectangle, except it would be in red, or you could just do a negative sign, draw it in pencil, and just write a negative sign on the inside. So that is what a zero pair is, how to show constants, and how we model variables. Alright, so now let's talk about simplifying an expression. So if I have an expression like 3x minus 2 plus 4 minus x, I'm going to use highlighters to show you kind of the pieces that you are allowed to put together. So this 3 has an x next to it. And this negative x is also an x. We call those like terms. They are the same thing. They're both letters. In my model, they would both be my rectangular pieces. So I have 3 x's and I have 1 negative x. So again, they look the same, they're the same shapes, which means that I'm allowed to put them together and make 0 pairs. My negative 2 and my positive 4, those are the same because those both do not have a letter next to it. So, and it also has to be the same letter when we combine like terms. For example, I could not put an X and a W together because they're not the same letter. So, 2 negatives, I would put 2 little circles. And for my 4 positives, I would put 4 yellow circles. Again, if you're doing this in pencil, you can draw the same shapes and just make sure you put plus signs for something positive and minus signs for something negative. So what I'm going to do is I'm going to make 0 pairs with my variables. So a positive and a negative taken away leaves me with 2 positives. And I'm going to make 0 pairs with my constants. And that leaves me with 2 positive constants. So here's my first picture where I did all of my crossing out. And here's my second picture that shows my simplified answer. So now the same thing can happen here. Remember that when there is not a number in front of x, that means that there's 1 x. So what is 3 minus 1? 3 minus 1 is positive 2 x's. That's what I have here in my picture. What is negative 2 plus 4? That's positive 2, again, which is what I have in my picture. So this is my work. This is my answer or my solution. You'll hear us call our answers solutions a lot. And then the same thing here. This is the work, and this is my solution. So basically combining like terms is showing that we can put pieces together that are alike. If the 2 pieces are not alike, for example, one is a letter and one is not, or they're not the same letter, if they are not alike, you cannot add them together. All right, let's move on. Hi everyone, and welcome to our lesson on solving equations. Now, we're just going to take some time quickly to do an example like I would do in class. I don't want you to write anything down just yet. I just want you to pay attention and try to take in the steps that are happening, and that way when we do go to take our notes, you will kind of have a little bit more of an understanding as far as like what you're writing. So, hopefully you can see everything that's on the board behind me. My problem for today is 4x plus 8 is equal to x minus 4. Now one thing that we are going to train to do is every time we get to an equal sign where we have to solve an equation, we're going to draw a line, kind of like a wall. We're going to split that equal sign right in 2, and what we are trying to do is basically move pieces across this line of equality. Now over here we have the model. We're not going to stay in model mode for a long time. You studied the models in 6th grade, in 7th grade. We're going to review them in 8th grade, and then we will pretty quickly transition out of using the models. All right, so on my model, just like I have 4 x's here, I have 4 positive green x's. I have 8 positive constants, just like I have here. I have my equal sign. I'm also going to split that equal sign in 2. I have 1x. On this side of my equation, notice how there's not a number in front of the x. That is a coefficient of 1. So anytime there's nothing in front, it is actually a 1. And then we have 4 negative constants, so that's what's represented here by my negatives. Now, I don't want you to get in the habit of thinking that you always have to move your variables first. It just so happens that that's what works best for this problem, which is why I'm going to do it this way. I could very easily move the constants first and still end up with the same result if I did everything correctly. All right, so the first thing I am going to do is pick a side that I want my variables on and that I want my constants on. So looking at this problem, just because, I want all my variables on this side and I want all my constants on this side. The same in the algebra. I want all my variables here on the left. I want all my constants on the right. So I have mentally kind of made that decision, and now mathematically, I'm going to start moving pieces around in order to make that happen. So again, I want my variables over here. So that means if I want my variables here, I need to take everything, all the variables, and move them over to this side. But mathematically, I wish I could just move it, but I can't. So the way we do this mathematically is I zero this out with a zero pair, and whatever I do to one side, I do to the other side. All right, what is that algebraically? I added in a negative x on the right, which also means I add in a negative x on the left. Notice how I did not write the x underneath the 8. They are not the same thing. 8 does not have an x with it. They are not like terms. So if you want to combine or add something, you have to put it underneath another term that looks like it. So I have 4 negatives and 0. I have nothing underneath 4 negatives. So think about that. What is negative 4 plus 0? It's still negative 4. If I have 1x and I take away 1x, well, what does that equal? 0. So that part goes away. I have 8 plus 0. What is 8 plus 0? 8 plus 0 is 8, and it's a positive. 4 minus 1x. What is 4 minus 1? 3. It's just that we're counting x's, so I'm going to write an x next to it. When we think about this math, notice how I kind of went down 4 separate problems. When we think about this math, we do the math the same way that you did math in elementary school. In elementary school, 4 minus 1 is 3. In algebra, 4 minus 1 is still 3. We're actually putting next to it what it is that we're counting. In elementary school, you might have had 4 apples, and you take away 1 apple, and you have 3 apples. Here I have 4 x's, I take away 1 x, and I have 3 x's. So we're just not counting apples anymore, but the math is still the same. All right, so now let's look at what happens here. 0 pairs get taken away, 0 pairs get taken away, because 4 minus 1 is 3. And just like my algebra, my picture shows the exact same thing. I still have 3 x's, 8 positives, and 4 negatives. All right, so now that I have moved all my variables over to my left-hand side, I want my constants over on the right. So how do I do that? Well, if I have 8 positives, I need 8 negatives. So let's go ahead and 2, 4, 6, 8 on one side, 2, 4, 6, 8 negatives on the other side. All right, well, what does this look like algebraically? I just added 8 negatives to both sides. All right, I have 3, and I'm adding it to nothing, so I still have 3 x's. I have 8 positives and 8 negatives, which cancel each other out, and now I have 0. Move that out of my picture. And then here, I have 4 negatives, and 8 negatives, and when I put 4 negatives and 8 negatives together, it equals to 12 negatives. all right? Which is what I have here. I have 3 positive variables, 12 negatives. So again, my goal in algebra is to isolate the variable, so I want to get down to just one variable. When a number is next to a letter, that means multiply. There's 3 of them. There's 3 of them. I don't need 3 of them, I need 1 of them. So the opposite of multiplication is division. I'm going to divide these into groups. And make sure my groups are all equal. In every group, I have 4 negatives. So I divided by 3. Let me get these out of the way. And 1x is equal to 4 negatives. So I divided my variables into 3 groups. 3 divided by 3 is 1. 1 variable. Negative 12 divided by 3 is negative 4. And this is our final answer. 1x is equal to 4 negatives. Okay, so that was our first example. I want to go through one more example. Again, I don't want you to be writing. This is me do, you watch, you absorb, and then in just a minute, I promise I will have you do a few more of these problems. Okay, let me just set up our problem. I will be right back in 5, 4, 3, 2, 1. All right, everyone, so here we go. We have 5 plus 5x is equal to 1 plus 2x. So I'm going to move all my variables to the left. I'm going to try to move all my constants to the right. That's the decision I'm making in the beginning. So now let's kind of make that happen. So the first thing I'm going to do, let's go ahead and move my constants over just to show that it's possible. You don't have to move the variables first. So I have 5 negative constants. The opposite of 5 negatives is 5 positives. What I do to one side, I do to the other. Negative 5 and positive 5 make 0. 5x and 0 makes 5x. 1 plus 5 is 6. And 2x plus nothing is still positive 2x. So algebra tiles, I added 5. So here's 1, 2, 3, 4, 5. And 5 to the other side, that's 1, 2, 3, 4, and 5 positives, sorry. Those are plus signs. These 0 pairs, 0 pair moves out, and I'm left with 5 x's, 6 positives, and 2 x's. So again, I have cleared out all of my constants on the left, and I've pushed them over to the right. The next thing I'm going to do is I'm going to take my variables on the right, and I'm going to pull them over to the left-hand side. Let's do the algebra first. The opposite of 2 positives is 2 negatives, and what I do to one side, I do to the other side. Take away 2. So 5 minus 2, remember 5 apples minus 2 apples gives us 3 apples, but again, we're in algebra, so we're not counting apples, we're counting x's or different letters. We have 6, and 2 minus 2 is nothing, so it goes away. When it comes to the algebra tiles, 2 negatives, 0 pairs, goodbye, 0 pairs, goodbye, and I have 3 x's and 6 variables. The last thing in algebra that I'm going to do is divide by 3, and what I do to one side, I do to the other, and before I go to my solution, divide by 3. Make equal groups, just like I would in division. I don't need all the groups, I just need one group. So 1x, because 6 divided by 3 is 2, 1x is equal to 2. Okay, so those are our algebra tiles. So these are the first 2 problems that we're working. Again, I didn't really want you to write anything down as much as I just wanted you to listen and kind of understand the direction that we're going with this. In the next video clip, you're going to see me writing notes in my notebook. You need to be writing notes in your notebook as well. All right, thanks. Okay, so we are on the second page of our notes. So we're going to work through another example just like the ones we just saw on the board, except for this problem, I do want you to write this problem down in your notebook. So the first thing that we're going to do is we are going to split our equal signs. Remember, we're building that wall of equality, and we're going to kind of move variables and constants across this wall. Alright, so the first thing that we are going to do is I am going to move my variables over to the right hand side, and I'm going to move my constants on the left. So like I said, I want you to kind of get an idea of what side everything is going to be on, and that way we know what we're working towards. So in order to move my variables over here, I have to do the opposite. The opposite of 2 positive x's is 2 negative x's. And what I do to one side, I do to the other side. So, just real quick, I'm going to grab my highlighter, and I'm going to show you that these 2 positives and these 3 positive x's I needed to combine and move together. So the way that I did that is by taking my negatives, and I had to write them under my negatives. So everything that is in yellow are like terms and can be added together. Everything that's in pink is like terms and can be added together. So I put everything in yellow together. Now this zeroes out. I have 6 positives is equal to 1x and 3 negatives. What does that look like in my picture? Well, I put in 2 negative x's on both sides. And what you will see is you will see things crossed out like this. So 2 get crossed out, 2 get crossed out. And then I'm going to draw my line to show I'm drawing a new picture. And on this one side, I still have 6 positives. On the other side, I have 1 positive x, and I have 3 negative variables. So the opposite of something negative is something positive. Let's move on to our next step. And like I said, these numbers need to be joined together, and this number needs to be. So we're kind of needs to stay alone. So what I'm going to do is I'm going to take this one pink piece, I'm going to move it over here with the 6. How do I do that? Well, the opposite of something negative is something positive. What you do to one side, you do to the other. And then you do the math portion. 6 plus 3 is 9. X and nothing makes x. Negative 3 and positive 3 is a 0 pair, and it equals 0. What does that look like with my tiles? Well, add in 3 positives. What I do to one side, I do to the other side. I cross out my 0 pairs, and I draw a new line. What I have now is I have 1x is equal to 9 positives. Okay, so 1 positive x is equal to 9 positives. If you don't have colors, you don't need to necessarily have colors. You can just draw rectangles with the positive and circles with positives or negatives in order to create your picture. So what the point of this is understanding the picture and what's happening in the picture and how it connects to what's happening with our equations. Again, also making sure that you're aware of like terms. I cannot take something that has a variable and add it to something that does not have a variable. That is not the way algebra works. So the highlighter is just there as a strategy so that you can make sure and add or subtract the pieces that are like and that go together.